Welcome to APCV 320 Computational Thinking and Doing. This week we will talk about the pseudocode and programming. The reason for this add-on presentation is to explain the pseudocode further for the students who are having a hard time in doing their assignment. Pseudocode is defined as a method of describing a process or writing a programming code and algorithms using a natural language such as English. It's not the code itself, but rather a description of what the code should be. In other words, it's used as a detailed yet understandable step-by-step plan or blueprint from which a program can be written. It's like a rough draft of a program or an algorithm before it's implemented in a programming language. It can also be referred to as false code or representation of code. The purpose of using a pseudocode is to provide a clear and concise description of the steps that will be taken in a process or algorithm without the need for a specific syntax or code. Pseudocode is not compiled or executed on computers. Keep that in mind, please. It's only meant to be read and understood by humans. So it doesn't have to be written by Python or Unix or Java. It's just a method of how we can interpret the issue that we have in hand, where we put the solution for it and it's understood by humans. So pseudocode is often used as a tool to create, design, or plan algorithms and prototypes. There are some graphical alternatives to pseudocode that can be used to represent algorithms such as flowcharts and UML diagrams. Here we will cover two examples on how to write a pseudocode. First example on calculating the average of 5 numbers. So as you see, we start with the word where it says start. Then you input the 5 numbers and store them in variables. We call them num1, num2, num3, num4, and num5. And then we do the calculation, which we say like, okay, calculate the sum of the 5 inputted numbers and store them in variable sum. And then we can say also calculate the average of the 5 inputted numbers and store them in variable AVG. And then you can say print the value of the variable AVG and then you end. So this is your pseudocode. It doesn't have to be executed by any programming language yet, because we assume that everybody's still learning and we're going to get into Python soon. Okay. So it can be seen that in the flowchart, the steps are laid out in a more graphical manner, while the pseudocode is focused on text. So in your case, guys, I would love to see like your example to be done as a pseudocode for the assignment, okay? The second example shows a pseudocode on how to calculate the area of a triangle. As usual, we go with the start, and then we enter the base length, which we'll call it B. And then we enter the height, which we'll give it the letter H, and then we calculate the area as 1/2 times base times height, and then we say display area and then end. So it's easy. This slide talks about the advantages of the pseudocode. So as you notice, we have several advantages that we can get by following the pseudocode protocol, because it's a simple way to present an algorithm or a program. It's also written easily in a word processing application and easily modified. Also, pseudocode is easy to understand and can be written by anyone. Pseudocode can be used with various structured programming languages. There are also disadvantages of pseudocode. Pseudocode is not a programming language, so it cannot be executed by a computer. And that's what I noticed some of you guys are trying to run the code by Python, and that's not what the assignment is about really. It's just to put your thought of how you can tackle a problem by following the pseudocode process. Also, pseudocode can be ambiguous and sometimes open to interpretation, which is okay, you know, nothing wrong with that. That's why like we have the discussion. And then also pseudocode can be difficult to read if not written in a clear and consistent manner. So you just need to be clear about what the problem that you have and how are you going to tackle it. Are you going to be covering every aspect of this problem in this pseudocode that we need for this assignment? Not necessarily, but just give me something that I can understand, like what's your thought process and how are you going to tackle that problem. Applications of pseudocode. It's often used in textbooks and scientific publication to describe algorithms, and this is very easy for anyone else when they look at that algorithm to understand what is this problem about and how did this researcher came up with that solution for it. Also, pseudocode is used by programmers when designing or planning a program. And this is because it can be helpful to write out the steps of a program in pseudocode before writing it in a programming language. So remember that, okay? Again, I keep reiterating, like what I said previously, that I'm not asking you to write me a code yet because I'm assuming we are not into Python yet, so I'm not expecting you to know how to write any code in Python. You just follow the two examples that I put and come up with something similar, and it makes it easier for you to come up with any issue and find an easier pseudocode of how are you going to tackle that problem. Syntax. Syntax is the basic foundation for a programming language. Different programming languages have different syntaxes. For example, the syntax for Java would be different from the syntax of Python, and we'll get to that when we start, like writing with Python. Okay, so don't worry about it. I just wanted to put this there just to give you a heads up, okay? Pseudocode does not have a specific syntax. This means that there is no set way to write it. See, it's just the way how you think about what the solution would be, and then you write your pseudocode. So because of this, pseudocode can vary in style depending on the writer, and that's okay because, as I said, there is no one solution for the problem. Could be multiple, so then it depends on the way how your thought process works. The following two different ways to write pseudocode for a program that calculates the area of a rectangle. We'll see like two different thought processes on how to solve this problem. So let's go with the style one. In style one, you go with the start and you say like, okay, get the length of the rectangle from the user. And the second statement would be get the width of the rectangle from the user, right? So we got the length and the width, and then we calculate the area by multiplying the width and by the length, right? And then we say print the area of the rectangle and end. In a style 2, for the same problem of finding the area of the rectangle, we say, okay, rectangle area, we open a bracket, we call it I or L, sorry, length, comma, W, which is the width, right? And then we say start, and then we define an equation called area equal length times width, and then we say return area, and then we end the pseudocode. So that's acceptable as well because it's a different thought process, right? So both of these pieces of pseudocode accomplish the same thing. However, they are written in different styles. There is no right or wrong way to write pseudocode. The last thing I wanted to address here is how to write a pseudocode, right? Because it's important for you to keep this in mind when you start writing your pseudocode. So as it says, while there is a lot of freedom in how pseudocode can be written, there are some common and structured aspects that most pseudocode shares. One structured aspect of pseudocode is the use of notation that represents 6 different common programming constructs. These constructs are sequence, while, if then else, repeat until, for, and case. So in the sequence construct is the most basic of all the pseudocode constructs. It represents a list of steps that are executed in order. For the while construct represents a loop, a collection of instructions that repeat until a certain condition is met, is referred to as a loop. If then else. The if then else construct represents a decision, right? A decision is a point in the algorithm where 2 or more paths can be taken. Repeat until. The repeat until construct is similar to the while loop. The only difference is that the repeat until loop repeats until a certain condition is met, whereas the while loop repeats while a certain condition is met. And then you have the for. The for construct represents a loop. A loop is a set of instructions that repeats a certain number of times. And then you have the case. The case construct represents a decision. A decision is a point in the algorithm where 2 or more paths can be taken. Yeah, this slide is a reference for the two sources that I used to make this representation. You guys can refer to them if you want to. This is the end of the lecture. If you still have questions regarding this subject, please feel free to email me.